Taxonomy is a hierarchical classification system of known methods of schedule impact analysis techniques and methods used to analyze how delays and disruptions affect entire CPM networks. Layer 1 Timing. Layer 2 Basic methods. Layer 3 Specific methods. Layer 4 Basic implementation. Forensic schedule analysis. Layer 1 in choosing the method of analysis is the timing. This distinction in timing is one of the most significant factors in the choice of methods. Also, the timing distinction is often mirrored by a change in personnel. That is, often the forensic schedule analyst who typically works in the retrospective mode is not the same person as the project scheduler who worked under the prospective mode. 1. Retrospective methods are performed after the delay event has occurred and the impacts are known. The timing may be soon after the delay event but prior to the completion of the overall project, or after the completion of the entire project. Note that forward-looking analyses such as additive modeling performed after project completion are still retrospective in terms of timing. In other words, even forward-looking analysis methods implemented retrospectively have the full benefit of hindsight at the option of the analyst. 2. Prospective methods are performed in real time prior to the delay event or in real time contemporaneous with the delay event. Consists of the analyst's best estimate of future events. Occurs while the project is still underway and may not evolve into a forensic context. Note: while some of the methods employ forward-looking calculations, they are still performed after the project is completed and are performed after the delay event has occurred and the impacts are known, and are therefore considered retrospective. The second hierarchy layer is the basic method consisting of two branches, observational and modeled. The observational method consists of analyzing the schedule by examining a schedule, by itself or in comparison with another, without the analyst making any changes to the schedule to simulate any specific scenario. Contemporaneous period analysis and as-built versus as-planned are common examples that fall under the observational basic method. The modeled method calls for intervention by the analyst beyond mere observation. In preparing modeled analysis, the analyst inserts or extracts activities representing delay events into or from a CPM network and compares the calculated results of the before and after states. Common examples of the modeled method are the collapse as built, time impact analysis, and the impacted as planned. Layer 3 Specific methods. The third hierarchy layer is the specific methods. Under the observational method, further distinction is drawn on whether the evaluation considers just the original schedule logic or the additional sets of progressive schedule logic that were developed during the execution of the project, often called the dynamic logic. 1. Observational methods. A static logic observation. A specific subset of the observational method. The static logic variation compares a plan consisting of one set of network logic to the as-built state of the same network. The term static refers to the fact that observation consists of the comparison of an as-built schedule to just one set of as-planned network logic. The as-planned versus as-built is an example of this specific method. The dynamic logic observation. The dynamic logic variation typically involves the use of schedule updates whose network logic may differ to varying degrees from the baseline and from each other. This variation considers the changes in logic that were incorporated during the project. The contemporaneous period analysis is an example of this specific method. Note that this category does not occur under the prospective timing mode because the use of past updates indicates that the analysis is performed using retrospective timing. 2. Modeled methods. The two distinctions under the modeled method are whether the delays are added to a base schedule or subtracted from a simulated as-built. Day additive modeling. The additive modeling method consists of comparing a schedule with another schedule that the analyst has created by adding schedule elements delays to the first schedule for the purpose of modeling the certain scenario. The additive modeling methods include the impacted as planned and some forms of the window analysis method. The time impact analysis can also be classified as an additive modeling method. This term or its equivalent, time impact evaluation, has been used in contracts and specifications to refer to other basic and specific methods as well. B. Subtractive modeling. The subtractive modeling method consists of comparing a CPM schedule with another schedule that the analyst has created by subtracting schedule elements delays from the first schedule for the purpose of modeling the certain scenario. The collapse as built is one example that is classified under the subtractive modeling method. Layer 4. Basic implementation. The fourth layer consists of the differences in implementing the methods. The static logic method can be implemented in a gross/periodic mode. The gross mode. The gross mode considers the entire project duration as one whole analysis period without any segmentation. Periodic mode. Implementation of the periodic mode breaks the project duration into two or more segments for specific analysis focusing on each segment. Because this is an implementation of the static logic method, the segmented analysis periods are not associated with any changes in logic that may have occurred contemporaneously with these project periods. The dynamic logic method can be implemented as contemporaneous, as if, contemporaneous split, contemporaneous modified, or recreated. Both choices contemplate the use of the scheduled updates that were prepared contemporaneously during the project. However, the as-is implementation evaluates the differences between each successive update in its unaltered state, while the split implementation bifurcates each update into the pure progress and the non-progress revisions such as logic changes. The purpose of the bifurcation is to isolate the scheduled slippage or recovery caused solely by work progress based on existing logic during the update period from that caused by non-progress revisions newly inserted but not necessarily implemented in the scheduled update. Modified or recreated. This pair, also occurring under the dynamic logic variation of the observational method, involves the observation of updates. Unlike the contemporaneous pair, however, this implementation involves extensive modification of the contemporaneous updates, as in the modified implementation, or the recreation of entire updates where no contemporaneous updates exist, as in the recreated implementation. The additive or subtractive modeling method can be implemented as a single base simulation or multi-base simulation. The distinction is whether when the modeling either additive or subtractive is performed, the delay activities are added to or extracted from a single CPM network or multiple CPM networks. For example, a modeled analysis that adds delays to a single baseline CPM schedule is a single base implementation of the additive method, whereas one where delays are extracted from several as-built simulations is a multi-base simulation implementation of the subtractive method. A single base additive modeling method is typically called the impacted as planned. Similarly, the single simulation subtractive method is called the collapse as built. The multi-base additive simulation variation is often called the window analysis.